So we're going to talk about something that may seem new to you, but I promise you, you have been doing for a long time now. You should be very comfortable with it. It's just different than what you're used to. We're going to talk about something called algebraic proof. Okay, algebraic should imply to you that it's going to use algebra, which is something you know how to do. Proof, on the other hand, is something that you have no idea how to do. So we're going to define what a proof is. A proof, and I'm pretty sure your parents will agree with me if you want to get them in here for this and ask them what they think about it. A proof is something that you have no idea about. A proof is an argument that uses, wait for it, logic. Okay, so at this point, you may argue a lot. Some of you argue with me on a daily basis. But normally, your argument lacks one key component, logic, which is why you lose. So maybe your parents aren't going to be happy with this because at the end of this class you're taking, at the end of geometry, you're going to have a lot more experience arguing using logic instead of just random emotion or wild outbursts, things like that. So a proof is an argument that uses logic. So I'm going to write down a problem that I am 100% sure every one of you can solve. All right, so here it is. 3x plus 1 equals 7. So I'd like you to go ahead and solve it. All right, this is what you should be doing. This is no big surprise here, right? Everybody that's in this class should have absolutely no problem solving this two-step linear equation. And we come up with x equals 2. Now, what you guys are doing that you don't know you're doing, but you're doing it, is you're solving this logically. I'm going to show you why. I'm going to draw some lines, just like you have on your paper. Now, hopefully, you're using the lines on your paper and it doesn't look like somebody just threw up pencil all over your paper, or even worse, pen. Okay, hopefully you're writing within the lines of your paper. If not, you should redo this and write it in the lines. Okay, we're going to talk about this equation that we just solved. Every single step here has a reason that you did it. It's not just something that I made up or that your math teacher, your algebra teacher last year made up and said, hey, I think we're going to try this way. Every bit of it has a logical reason for doing it. Okay, the first thing you wrote down was this statement, this equation that I told you to write down. Now, this may seem kind of silly, but why did you write this on your paper? Well, you wrote it because I gave it to you. So this is called a given statement. So this is my given statement or given equation. It was given to me. If I gave you nothing, you would just have a blank piece of paper. So every time you do a proof, something's got to be given to you. Now, the very first thing you did was subtract 1 from both sides. Nobody in all of the world would have done this problem any different than you did. That's the first step. And the reason every single person in the entire world would have done this on the very first step is because they all know the subtraction property of equality. Now I can see my lines are going to have to get a lot longer, right? Let's stretch this out a little bit. So hopefully you've realized by now that this section in geometry is going to be very writing intensive. All right, so the subtraction property of equality tells us that we can subtract anything we want as long as we do it on both sides of the equal sign. Now the next step right here, we went from 3x plus 1 equals 7, subtracted 1 on both sides, and wound up with 3x equals 6. Well, the reason we did that is not because of any special property or any special rule in math that we've learned. It was just us simplifying our equation, simplifying our problem, right? I could leave all this garbage in there. I could leave it looking like this. Right? I could have jammed all that up in there and had this just mess going on, but I don't want to do that. I simplify, and so do you. The next step, the reason we've divided both sides, is something called the division property of equality. Okay? So as long as you divide both sides of the equal sign by the same thing, you can do whatever you want, right? I didn't have to divide both sides by 3. I could divide both sides by 50, or 1,000,000, or 100, or a smiley face. As long as I did the same thing on both sides, doesn't matter. And that is called the division property of equality. Now the last thing I have here is I simplified this, right? I crossed out my 3's. I did 6 divided by 3 is 2, but it's really, I'm just simplifying it, right? Because 6 over 3 is the same as 2. 2 is just simpler. So simplify. Now this is an algebraic proof. This is probably not how you're used to solving problems. If you're a couple of specific kids in a couple of my classes, this is probably going to make you cry because you like to go from this step to x equals 3. Notice I said x equals 3 because you get it wrong because you skip all the steps. So you're not going to be able to skip steps on this stuff. You're going to have to write every single step and you're going to have to give a reason. So what I want you to do right now, and this is not going to be popular, and that's okay, because this isn't a popularity contest, it's a math contest, is on page 104 in your textbook. Page 104 in your textbook, there is, and you don't need to write this down because you're going to do a lot of writing here in just a second. There's a table that says properties of equality. Okay, you need to write down every one of those properties of equality right here in your notes. All right, so you should have your properties in here by now. We're going to do a little example of how this works. You may get a problem like this. It says C is between A and B. AB equals 5x minus 4. AC equals x plus 3. And CB equals 2x minus 1. Okay, you've seen problems like this, right? We just had a test. Some of you just failed a test that has problems like this. Some of you just failed a retest that has problems like this. So this should be a tip to you that this kind of thing is not going away. You're going to have to be able to do this. So what's the first thing we need to do when we do a problem like this? Hopefully you're saying we need to draw a picture. So I'm going to draw a nice little segment. It's going to have an A, it's going to have a B, it's going to have a C. Now the C is not in the middle, it's just between. Now it tells me that from A to B is 5x minus 4. A to C is x plus 3, and C to B is 2x minus 1. So hopefully you recognize that this is a part whole problem. And with a part whole problem, we add up this part plus this part, and we set it equal to this part. But why do we do that? What gives us the right to do that, or the knowledge that that's something we can even do? I'm actually going to move this just over here. No big deal if you can't do that, sorry. But I'm going to move it over there. Why can I say that this part plus this part equals this whole part? Just because that's just how it is and I like it? Or is there a reason? And you'll find that in math there is a reason for everything. So the reason that I can do this part whole, the reason that I can say that AC plus CB equals AB, the reason I can say that is because of some fact that I've already learned. So let's talk about the facts that we've learned. We've learned lots of postulates. We've learned several definitions. We've learned lots of things. But one thing in particular tells us that AC plus CB equals AB. And that one particular thing is called the segment addition postulate. That postulate we learned told us that this piece plus this piece equals the whole piece. So now I know that AC is x plus 3 plus CB is 2x minus 1, and that all equals 5x minus 4. Well, how did I know that? How did I know that information? Well, one, I could say up here it was given to me, right? This is given to me. All of these things, I already know them. But why did I go from this to this? Why did I go from writing the letters AC to writing the expression x plus 3? And if you look on your table up above here that you should have written in your notes, you'll see something called the substitution property of equality. The equal sign is important there. It lets me know that it's a property of equality. Later there's going to be properties of congruence. They're going to need congruent symbols. So there's my reasons for all that. So I'm going to keep going. I'm going to keep solving this problem now. What's the next thing I want to do? I'm going to look here. I can see an x and a 2x. And I can see plus 3 and a minus 1. Well, I want to stick those together, right? Because I'm really good at algebra. And the reason I want to stick those together, though, 3x plus 2 equals 5x minus 4. Why can't I just combine those together? I just feel like it. Just do whatever I want. Hopefully you know it's because I can combine like terms. You can also just say simplify here. Either one is fine. They both mean the same thing. So we're going to separate this. You can see this is not algebra that you're used to, right? This is getting pretty intense. Now, the next thing we're going to do is subtract 3x. And I'm using a different color here because this is one of our big steps that we do in math, right? Why do I know I can subtract 3x? Well, I'm doing it on both sides of the equal sign, so that means it's the subtraction property of equality, right? Now pay careful attention. A lot of people put SUB for subtraction. They abbreviate it. How do I know they didn't mean SUB substitution? So it's just a few extra letters to just write it all the way out. So don't take the easy road out. Write these things all the way out. Just abbreviate the little parts at the end. But the big important part, write that out. Alright, so now 3x minus 3x, well that goes away. 2 equals 5 minus 3 is 2x minus 4. Well, that step was nothing special, right? That was just me kind of simplifying everything, so that's simplify. So I'm going to keep on going here. And this is the exact kind of algebra you know how to do, so this isn't anything revolutionary here. Now I'm going to add 4 to both sides. And the reason I can do that off your little table is the addition property of equality. I would suggest that you guys make a flashcard for every single one of these properties. And you can roll your eyes, I can see you doing it from here. But okay, we're not going for 70s on these tests, right? Nobody that's in the pre-AP program is going for passing, right? We want perfection. We want to make hundreds on these things. So it's time to get serious about it. You need to make flashcards, and you need to know every one of these properties that you wrote down. 2 plus 4 is 6 equals 2x. Well, again, that was nothing special. That didn't require any kind of special property. That was just simplifying. You see how the math process that you're used to is about to get much more lengthy, right? So the next thing we're going to do is divide both sides by 2. And we can do that because of the division property of equality. So 6 divided by 2 is 3. 2 divided by 2 cancels out because it's 1. So we just have 1x left. So x equals 3. Now, how did I go from this to this? I could have just left 6 over 2. We all know that's 3. So that's just another case of basic simplifying. And we're almost done. Normally you would be done, right? If this was just a plain old question that said find out what x equals, you'd be done. But it's not. This is a proof. So a proof needs to go all the way down to the very, very end and finish off with x equals 3. Now what makes me be able to just switch those around? Just because I'm a nice guy and people like me? Or can you look on your properties and find a reason why I can say that 3 equals x and x equals 3 can be switched around, can replace each other? And hopefully you see there is a symmetric property of equality. So that is your first introduction into a real proof. We're going to work on them a lot in class tomorrow, but if you've ever heard the phrase, the devil is in the details, that's what all this is. All of these details. If this were a test question, each one of these lines would be a point. And the reason that goes with it would be a point. And if you're one of those people that likes to start with x plus 3 plus 2x minus 1 equals 5x minus 4, and you like to pick up your calculator and jam it all in and write down 3 equals x and do this, you're going to lose a lot of points on this problem. So I would take this seriously. I'll see you tomorrow.